I'm Marta. I'm an INet board member, INet-NYC board member, and today I will introduce you a little bit about INet and about our speaker and the event of today, and then I will just leave the stage to Christina. So before starting, let me just give you a brief introduction about INet. INet-NYC stands for International Networking in New York City and is an organization founded in 2014 with the main aim of supporting and offering professional development and helping building community and networking, mainly addressed for scientists, international scientists in STEMs in the New York City area. We support our mission by the organization of career development events, networking and social events, by sharing research opportunities inside and outside the US, and also by organizing important info sessions for topics that sometimes for us are really tricky and important, such as immigration or taxes. Our network is composed by several board members like me, who are scientists working in a research institution in the New York area, and by more than 900 members who are mostly foreign scientists in training in STEM. We would like you to join us, to join our community, either becoming a member, and in this way you could subscribe and receive our newsletter so that you can get a lot of information about what we do and our events. And if you like what we do and you would like to be even more involved, you can apply for open positions. We actually currently have some of them. So you can check out in our website, INet-NYC.com, or you can write us an email for any information you may need. We are also very active on our social media, so check them out, such as our LinkedIn page, Facebook, Instagram, Twitter, and also our YouTube channel. And we will be posting actually the recording of this event. Talking about upcoming events, we usually organize one event per month, and next month is the mental health month, a topic that I guess for scientists is quite important, right? So we will be organizing an event dedicated to that. More details will come soon, so stay tuned and check more about this event. And with that, I just would like to acknowledge the INet co-founders, Ariola and Mike, our advisory board, and all the sponsors and partners that are helping and supporting us in our event and in our association. So I just stop sharing my screen and all right. And so again, thank you very much for being here with us today, to our attendees, and thank you so much to Christina. I just briefly, as I told you, want to launch the first poll, which is going to ask you what is your current job role, so that for us and for Christina, we will get a sense of it. And in the meantime, I just want to introduce you another INet board member, Lucy, who is who organized the event together with me. So will be the moderator of the event of today, and she will take your questions and ask your questions to Christina. So thank you, Lucy, and hi.
Hi, thank you all for joining us tonight.
Yeah, and thank you so much to Christina for being here with us. Christina Greever is the Sustainability Program Manager of the nonprofit organization Mind Green Lab. And today she will give us some tips about how to become greener scientists. And also she will talk about all the programs that My Green Lab is running to help us really to reduce the impact of our research. So we're really very happy to partner with Christina today because we really care a lot about this important topic. All right, so I will say that almost all of you voted. I will just give you a few seconds more, and then I can share the results of the poll. Okay. So as we can see, we are mostly postdoc and graduate students, and then there are some lab managers, technician, professor or PI, and then 10% is others.
Wonderful.
Yes. So, Christina, I stop sharing results, and you can start whenever you want with your talk. Thank you so much.
Wonderful. Let's get my screen shared. All right. Well, thank you so much for all of you spending a little bit of your time this evening and during Earth Month with me. And it's really great to be here. I really appreciate the invitation from INet-NYC. So my name is Christina, and I work for the nonprofit organization My Green Lab. And I'm currently our sustainability program manager. I've also served as our operations manager, and I did social media for My Green Lab for a year when I was transitioning out of my previous role, which was at the University of Colorado Boulder, working for that Green Labs program there. I have a biology degree from Lewis and Clark College, where I did my undergraduate. And I have a few years of research experience, and then I moved into research compliance and now laboratory sustainability. And I've been in this field for the last 5 years and been with My Green Lab for about 2.5 years now. So today we're going to talk about both the environmental impact of scientific research around the world, and also what can be done to mitigate and lower your environmental footprint. I will share with you a little bit more about what we do at My Green Lab, but let's talk about some facts and figures first. And start with this question of why do we need sustainable science? If you're here with us this evening, it seems like you already have kind of an affinity for this topic and want to know how you might be able to change the practices in your lab to not have such a large environmental impact. Obviously, science gives us insight into the world around us, above us, below us, and helps create the basic building blocks for new materials and technologies, advancing human health, animal health, and the well-being of everyone on our planet. But there is quite a large environmental impact to how scientific research is conducted today. And to start off with, laboratory buildings can consume 5 to 10 times more energy than office buildings. And what this means is that laboratories actually present a great opportunity to work on energy conservation, where small changes that you make and things that you pay attention to better in your lab, this can have real impact, maybe even a more pronounced impact than, say, changes you might make to be more sustainable at home or in your apartment. Not every laboratory obviously looks the same. You all have different equipment, different research aims. So coming up with sustainable solutions for labs can be kind of complex. But those of us that are trying to implement changes and promote change, behavior change in the lab sustainability movement, we actually look to you, the scientists, in order to figure out what new best practices can be promoted and what changes can be made. Often scientists are the ones that are coming up with great ideas for being more resource conscious in labs. Many of us that work in the laboratory sustainability field have been scientists before, and we have seen the direct impact of our research on resource use, and that's what drives us to be involved in this community. And you can be involved too as a scientist. So let's start with a few examples on the energy front. Ultra low temperature freezers are a very common piece of laboratory equipment. And My Green Lab did a study a few years ago in collaboration with the Center for Energy Efficient Laboratories, which is kind of a consortium we formed to do research like this. We estimated that there are 500 to 900,000 ultra low temperature freezers in the United States alone. So think about what that means for the impact of ultra lows around the world. And a single ultra low can consume about the same amount of energy as a small house each day. But luckily there are some things you can do about this, which I'll talk about a little bit later. Similarly, fume hoods are very ubiquitous in labs. If you're in a chemistry lab, you might have upwards of 10 or more fume hoods in a very fume hood driven space, or you might have just 1 or 2 in your lab space. It's an important tool, obviously, to keep you safe, but a single fume hood can consume the same amount of energy as 3.5 US single family homes in a day. And if you think about it, fume hoods are actually taking air that has been heated or cooled and humidified that's pumped into your lab, and then they're venting it straight off of the roof continuously, 24 hours a day, 7 days a week. There's not much you can do to turn off a fume hood, but there are some things you can do to lower the energy use of your fume hood. And just a closer look at energy overall, energy in labs. About 1/3 of the energy consumed by labs is related to your lighting and your plug loads. And this is the part of energy use that's really within your power as scientists to influence. So that's really great news. And a typical laboratory building can use 2 million gallons of water per year or more. And similarly, if we take a closer look at that water use, about 1/4 of the water use in your lab is directly related to your lab processes. A single autoclave can use 5,000 gallons of water per week. And if your lab does any single pass cooling, in other words, using tap water to cool reactions or equipment that's not recirculated, but single pass through, tap water down the drain to cool things, that can use 15,000 gallons of water per year. So water and energy are a bit more hidden in the lab. They're not as obvious as, say, your single-use plastic use. But it's still important to focus on these types of resource use, energy and water. For water, think about what types of equipment are being cooled by water, dishwashing, autoclave use, ultra pure water systems that are in use. And then obviously the water that's needed to cool your laboratory building. Laboratories discard over 12 billion pounds of plastic each year. This is an estimate that came out of the University of Exeter in the United Kingdom back in 2015. This is probably a conservative estimate because that estimate actually didn't include all types of laboratory research. 12 billion pounds is about 2% of global plastic production, and it's the equivalent of over 4 billion single plastic water bottles. So we know laboratories are discarding a lot of waste. I'm sure this is one of the most visible things that you see in the lab, whether it's the single-use plastics and other consumables that are necessary for doing your work, or it's the packaging that all of that material comes in, or even the packaging that your reagents are shipped to you in. There's hazardous waste and biohazardous waste, and even a growing quantity of e-waste coming from labs as more of our pieces of equipment become high-tech and have electronic components. So we can talk about reducing, reusing, and recycling materials that come into your laboratory. But I think it's also important to think upstream as well. And what I mean by that is trying to prevent waste from coming to your lab in the first place. And even though you are not developing laboratory products, you are voting with your money, basically, or you have a voice with what you choose to buy. And you are an extraordinarily important voice to the people who design and sell laboratory products. So just want to have you keep that in mind. There's also social justice implications for where our laboratory waste goes. I've done a lot of thinking about this over the past few years and given some talks on it. I've specifically focused in on hazardous waste, hazardous chemical waste. And I know of a few examples of academic research institutions that discard over 100,000 pounds of chemical hazardous waste. either destined for landfill or incineration every year. So as you can imagine, green chemistry is also part of the solution for reducing the amount of waste coming from your labs. So I'm not sharing all of this with you to overwhelm you. You work at your lab bench and you see what goes on in the lab every day. There's probably particular aspects of what I just discussed that elicit a strong response in you, whether you're more passionate about water or energy or waste or the chemicals. And what I want to share with you today is some hope and some ideas for how we can combat all of this resource use that is an integral part of science, but we're hoping to change that and make science more sustainable on a global scale. So I feel that labs are really an untapped opportunity for bringing sustainability out. They are a final frontier of sustainability in a lot of ways. You are able to have a large impact by making small changes in your lab and sharing what you're doing with other scientists that are a part of your network. I really do think it's true that science is one of the final frontiers of sustainability because labs are so complex, because every lab is different, because every lab has different needs, and obviously your science is of utmost importance. You need to be able to continue doing your research. But I do think that there's a way to bring sustainability in to scientific processes in a lot of different ways. And your voice in this whole process really matters. And I just want to point out that you might have noticed a growing focus on lab sustainability in publications, in podcasts, in popular media over the last few years. We think this is a great thing, getting the word out to more and more scientists. Nature and Lab Manager have run entire segments on lab sustainability. Lab Manager devoted their April issue last year to greening labs. And I would say that even in the last year with the unfortunate COVID pandemic that we are currently in, talking about ultra low temperature freezers and the energy use of these large freezer farms that are necessary for the vaccine rollout. These are all things that are coming into the popular media and being talked about and elevating the awareness even further of the large resource use in labs. And then there's the fact that many companies have come together through the Green Chemistry and Commerce Council and other entities as well. They've come together to state how important knowledge of sustainability and green chemistry is to the training of the next generation of scientists and engineers that these companies are going to want to hire. They've made public statements about how green chemistry knowledge is necessary in order for these companies to compete in the global economy. And these are companies like Dow and DuPont, Johnson & Johnson, MilliporeSigma, Nike, 3M, a lot of powerful large corporations that want to see greater focus on sustainability and green chemistry. Not only that, but universities are making commitments to lab sustainability and green labs in general. We are seeing more and more institution-based green labs programs growing around the world. There are many such programs in the United States. Europe is maybe going to overtake the United States shortly with the number of these programs that are affiliated with a particular research institution. And we are working with more and more labs all over the world, not just in the United States, with our programs. Some university systems, like the University of California system, are now mandating that every one of their 10 campuses has a Green Labs program, and they're reporting on it each year in their sustainability outlook and goals. And really interesting, a couple of years ago, about a half dozen universities in the United Kingdom band together to pledge going plastic free. And they also mean plastic free in their labs, which is a huge commitment, but there is support across those institutions to make that happen, which is so incredible. And then we also have leadership and interest in lab sustainability coming from private industry. So biopharma companies, biotech companies that are developing their own Green Labs programs. Some of them are utilizing our programs and tools. And by committing to greening their production processes, manufacturing, distribution, and R&D, these organizations are trying to put resources and where they're making these sustainability statements. They're trying to really join word and action together, which is wonderful to see. So all of this is to say that you are not alone in caring about reducing the environmental impact of science. This is a growing, exciting field, and there are many people around the world that are trying to do something about this issue, that science is very resource intensive. And I'd like to say to you today that, like an ecosystem, we are all stronger together. So I love that you've joined me today and joined this conversation. And I would like to present you with some ideas about how you can get started in your lab. And all of this, helping scientists find ways to reduce the environmental impact of science. This is what My Green Labs programs focus on. We want to help people see possibilities of making change that still work for your research. So My Green Lab is a US-based nonprofit organization, but we do work with labs all over the world. Growing, we have a lot of growth going on in Europe and the United Kingdom at the moment, but we will work with anyone all over the world that is interested in greening up their laboratory practices. And our team is made up of experienced scientists and sustainability thought leaders, and we are all very passionate about laboratory sustainability and the Green Labs movement. And we are trying and working towards creating a culture of sustainability through science. And we do this in a few different ways, by bringing awareness to the environmental impact of laboratories, and then by sharing resources and best practices and supporting scientists through our various programs. And we also kind of serve as a nexus and a connector between many different aspects of the lab sustainability community. And we help scientists explore ways to reduce the environmental impact of their work. And by you engaging with both My Green Lab and just in lab sustainability in general, you're joining a global community of people that are working towards these same goals. So I hope that provides a very positive, hopeful outlook to you, that you can start where you're at, and you can work on making changes that are available to you and accessible to you and your work, and that there is a growing team of people all over the world that are doing the same thing. So we can have exponential growth and impact by doing this together. All right, so I want to launch another poll.
Do you want us to do it for you, maybe? Or is it okay?
No, I just figured it out. So if people could respond to this poll, what does it take to foster a sustainable lab? And I'm just interested in what you think. Don't be shy. And thank you for participating. The next phase of my talk, I'm going to provide some concrete examples and ideas of how you can be more sustainable in your lab. All right, I think I'll end the poll and share results. Can you all see that?
Yes, I think.
Cool. Great. So I guess this was kind of a trick question. There's only one, there's no wrong answer here. Although I would say option number 3 is maybe the one I associate least with transforming your lab into being a sustainable lab. But thank you all for participating. We'll talk about some of these ideas. I definitely think that if you have passion, creativity, curiosity about how you can do better, if you're willing to change your behavior, I should have also probably put here, willingness to talk to other people, because you're going to have far more impact if you're willing to tell your friends and colleagues about what you're doing in your lab to be more sustainable. I think a little bit of time and some drive and curiosity is probably the biggest things. A lot of the sustainable solutions that we propose don't cost any money, or they are very inexpensive. And yeah, so a little bit of time and a little bit of other special things sprinkled in there. So let's get started with this segment of the talk. So I want to start with reducing, reusing, and recycling materials from your lab. Again, these 3 words, I guess, are related to downstream actions. So once the materials are in your lab, what can you do about them? But I would also encourage you to think upstream again. And some of our programs talk about that as well, like our Green Lab certification. A great place to start with addressing waste is get to know your waste streams and figure out what your largest waste streams are. You might think you know. If you do purchasing for your lab, you probably do know. But if you don't do the purchasing for your lab, you might think that the largest waste stream is gloves or pipette tips, just because you're handling them and touching them every single day. But if you actually dig into your trash or your recycling and figure out either the volume or the weight of your different types of lab materials that you're discarding, that might give you some insight into what to focus in on first. Maybe just pick the 2 or 3 things that you're generating the most of. You don't need to change everything in your lab all at once. All right, so you can also take advantage of vendor take-back programs and recycling programs. There's mail-back programs for expanded polystyrene, so your white foam coolers that come from both New England Biolabs and Promega, I think, is the other one that does the take-back or Sigma Aldrich. And if you're receiving materials from companies, you can ask them if they have take-back programs or if they've thought about doing take-back programs for their materials. I would love to see more of these types of programs. There's also some glove recycling programs, pipette tip box take-back programs, and recycling programs. So take advantage of these that are in your area. This is very region specific in the United States, unfortunately. Your lab can share a common supply or base supply of reagents and chemicals. And then you can aliquot out or dilute from there. And this helps prevent your lab from over purchasing or maybe losing track of a few bottles and then they expire and then you don't know what to do with them or need to discard of them as hazardous waste. Try consolidating orders from particular vendors. So maybe try and make sure you're not receiving multiple boxes from New England Biolabs each week or Millipore Sigma each week. Whoever you're ordering from, try and consolidate vendor orders. You can also, I don't know if your institutions have these now, but there are these little kiosks that are set up by your vendor. It's kind of like a vending machine for reagents. And that's kind of a cool sustainability idea, and hopefully it's useful to you too and convenient. But you know, the vendors are stocking those directly, and so you're eliminating a lot of that packaging that you know, ends up in your supply room or your storeroom when things are shipped directly to you from the vendor. If you can use those vending machine type situations. You can cut down on packaging, which is really neat. Hopefully we see more of those popping up around our institutions. And again, talk to your sales reps about whether they will take back packaging or even products and equipment at end of life. The more that you talk to them about sustainability and express to them that sustainability is important to you, and I know it can be scary to voice your opinions about this sort of thing or raise your voice about it, but they really care what you think because you are their customer. All right, so we can also reduce waste through green chemistry. And remember, green chemistry doesn't just apply to chem labs. Any laboratory that uses chemicals, not just a chemistry-focused lab, can implement green chemistry practices. There are 12 principles of green chemistry. If you want to learn more about this, Beyond Benign has a wonderful website, and they're a wonderful organization that focuses on green chemistry. So discuss the 12 principles of green chemistry with your lab and see if there's anything that you can change about your lab practices, reactions, protocols that you have to follow. This could involve thinking about whether any of your lab processes could be done at ambient temperatures and pressures. You can use greener solvent selection guides to try and trade out some of the most toxic or hazardous chemicals that your lab uses with more benign chemicals. And another great place to start is just eliminating mercury-containing products from your lab, whether it's thermometers or bulbs for your microscopes, other lamp elements. And a lot of institutions, if you talk with your environmental health and safety team, they might be willing to chip in some money so that your lab or your institution can trade out all of those mercury-containing materials for non-mercury containing materials, just because it's such a mess and so toxic when anything with mercury breaks. So you can reach out to EH&S at your institution and see if they'll help your lab with this. All right, rethinking energy. So this is a no-brainer, but sometimes it doesn't happen. I've walked into many labs first thing in the morning when nobody's there and the lights are all on and the doors are sometimes even open. So make sure the lights get turned off in your lab and support rooms at the end of the day. You can also figure out what pieces of equipment in your lab might be able to be turned off at the end of the day. And you can do this in a few ways. You can assign a task to someone to go around and turn off pieces of equipment at the end of the workday. For types of equipment that your lab has chosen are good candidates for this. Maybe PCR machines, vortexes, a lot of that smaller benchtop equipment. Your lab might leave on 24/7, but those might be good candidates for turning things off overnight. You can also try using outlet timers so that your equipment automatically gets turned off at the end of the day. And you can set it up so that it's powering things on a few hours before the first people get into the lab so that things are warm and ready to go for the workday. A lot of your equipment also, and especially newer equipment, might have sleep modes or energy saving modes. Especially look at glove boxes for eco modes, drying ovens, incubators, those sorts of things. Just look at your equipment and figure out if there's any special features that might be useful to you. And don't use screensavers on your computers. I think this is less common now than it used to be. This is just a case study that was done by Johnson & Johnson at their La Jolla site. They metered equipment and then put their equipment on outlet timers and did metering again. They chose just a bunch of water baths and a heat block, and installing 24 outlet timers on these various pieces of equipment saved a really easy $360 per year. And that's the equivalent of driving nearly 9,000 miles in a car. Outlet timers don't cost very much money. They're like $5 to $10 each. I have some opinions about the best types of outlet timers. If you'd like to know more, feel free to email me. But this is a really easy, low cost thing that you can do to ensure that your equipment isn't left on all the time. A great thing to do is be good with your fume hood. We talked about how much energy your fume hood is using, but making sure you shut the sash in your fume hood can save 2 homes worth of that 3.5 homes worth of energy that these fume hoods are using each day. Shutting the sash is really one of the best things you can do. It's great for sustainability. It's also great for safety. Just keep your sash closed when you're not standing in front of the hood. And this is especially true if you have variable air volume fume hoods. And you can ask your building manager about what type of fume hood you have. If you do have VAV hoods, variable air volume, which means that the velocity of the air changes as you close the sash. It like opens a baffle at the top and actually reduces airflow when you close that fume hood sash. Those especially are the best types of hoods to be always sure you're closing the fume hood sash on. You can do a lot with your cold storage too. As I mentioned before, ultra low temperature freezers specifically can consume the same amount of energy as a house each day. You can chill up your ultra low from -80 degrees Celsius to -70 degrees Celsius, and this can save about 30% of the energy that unit consumes. When your lab has to purchase new freezers or refrigerators, be sure that you're purchasing Energy Star units. The Department of Energy has created Energy Star ratings for laboratory refrigerators and freezers now. And there's a wide selection to choose from, and you can peruse that on the website. And this is a great way to cut energy use right from the get-go when you're making new purchases. Keep an inventory of your samples so that you don't keep having to buy new units, and do periodic sample cleanouts. And then you can also do some preventative maintenance to make sure your refrigerators and freezers are running as efficiently as possible, making sure there's no cold air leaking out of your unit. Maintain and fix your door seals if they crack or break and you do have leaking air. Periodically defrost your freezers and make sure your vacuum coils and the coils and your filters are clean. Just doing that alone can save 10% of the energy of your freezers. For water, think about where water is used most often in your lab and focus on those processes first. So some examples of this, if your laboratory sinks, when you turn on the water, are like splashing a bunch, and it's really gross because you don't know what's in the bottom of your lab sink. Low flow aerators can help you reduce water usage at your lab sinks by 50 to 70%. That's probably something you want your building manager to help you install, but they're just a tiny little device that reduces the water flow. Hopefully your lab isn't using single pass cooling for synthesis reactions, but if you are, you can try some alternatives to using tap water for this, such as waterless condensers. There are a few different types. I'll show you a picture of one on the next slide. Try and run your autoclaves and dishwashers when they're full, not just anytime you feel like it. That's usually what we do at home too, right? So think about what you do at home and how that translates to the lab. And then use the right water quality for the tasks you need, not for everything. It takes 3 gallons of water to make a single gallon of deionized water. A case study from a university lab at Berkeley, there were 6 labs using single pass cooling for lab processes. And this was using 3,600 liters of water every 24 hours that these condensers were set up and running. And sometimes these labs would use single pass cooling for days at a time. And so the university invested in waterless condensers. What's pictured here is a brand called Findenser. There's also a glass version that's made by a different company. And basically they use surface area to cool, surface area and air to cool your reaction instead of water. And these work quite well for certain types of reactions. And this single case study, this saved 1.7 million gallons of water per year for Berkeley. That translates to about $7,000 in water savings. water isn't that expensive usually for our research institutions, although I would argue that it probably should be more expensive for fresh water. But it's still best not to run clean tap water down the drain if we can avoid it. So with those tips and suggestions, let's transition to the final part of my talk, where I can share with you how My Green Lab can help support you in your quest. This is an image of a quest to make your lab more sustainable. So I'm going to launch the final poll here real quick. I'm just curious to know which of our programs you might have heard of already before this talk. Had you heard of the Freezer Challenge, Green Lab Certification, the Ambassador Program? And it's okay if it's none of them. We're going to change that right now. All right, 10 more seconds. All right. Thank you all for responding. I'm just curious about this. So for those of you who have never heard of My Green Lab's programs, I'm going to introduce you to a few of them today. I love that some of you have heard of the Freezer Challenge and Green Lab Certification and the Ambassador Program. Awesome. So at My Green Lab, we have an ecosystem of sorts of programs available, designed so that individuals like yourselves, laboratories, institutions, suppliers, that all of you can interact together and engage together to transform how science is done around the world. We work with laboratories from all sectors. We work with federal labs, we work with biotech, biopharma, academic laboratories, a ton of academic institutions, clinical labs. We're even kind of getting into quality control, food science, cosmetics, with our Green Lab certification. And as I mentioned before, we do work with labs all over the world. So I'm going to introduce a couple of our programs to you now. And the first one I want to mention is our Green Lab certification. This is sort of like our flagship program. We have certified hundreds of labs at dozens of research institutions in many countries all around the world. And our aspiration for our certification is that it becomes the international gold standard for laboratory sustainability best practices. And this program does cost labs a little bit of money. We want to make it affordable, so it doesn't cost a lot. And so for our feedback report for academic institutions, it's about $175 to go through the Green Lab certification process, just as a heads up to you. But the certification focuses on behavior change in your lab. So behaviors and actions that scientists actually have influence over. So we don't really go into too much of like the laboratory building itself. We work with whatever infrastructure is available to you and focus more on like the equipment that you choose to purchase, the consumables, and yeah, talk a lot about behavior change. So the way this works is it's an online self-assessment to get a baseline of your lab's best practices and sustainability practices. And then we provide suggestions for areas of improvement. And our certification is designed around these 14 topic areas, which are very common to a lot of labs. And if your lab doesn't have some of these, you're not faced with questions about, say, animal research if your lab doesn't do animal research or field research. So your lab would take the baseline self-assessment and we would take a look at what your lab's already doing and give you a bunch of suggestions for making sustainable changes. And then you're given a period of time to implement those changes, and you can pick and choose what you want to do. Our certification is in no way prescriptive. You really take the feedback we give and you decide what parts of it you want to implement in your lab. And then you take the self-assessment a second time after a period of usually a few months of implementing your changes. You take the self-assessment again and you get certified. And then there's a recertification process after a few years where we take another look at what you're doing, you make more changes, and provide feedback again and recertify. I believe we're doing this every 2 years right now for most labs. So it's really a great way to get a snapshot of what's going on in your lab and how you can make improvements. We ask that everyone in the lab takes the self-assessment and that at least 50% of the people in your lab respond, and that you all do the assessment individually and give your own honest answer of how things are in the lab. And of course, we want to recognize your success and your ability to implement changes. And so our certification, you can get certified at a variety of levels. Bronze, silver, the gold level, platinum, and our top level is green certification. And what these different levels mean is just the percentage of sustainable actions that your lab has implemented that are covered on our survey that are applicable to your laboratory. And we feel that green labs are certainly good for you in a variety of ways. For you as a scientist, we help raise awareness for you and your colleagues about the environmental impact of laboratories and what you can do about it. You're also able to prolong the life of your equipment, say for implementing some of those preventative maintenance best practices for your cold storage. By embracing sustainability as a cultural aspect of your lab, you can attract the next generation of researchers to your lab, because we know that a lot of the scientists coming up through graduate school and even undergrad now, sustainability is really an important aspect of all aspects of your lives. And you're then able to have a positive impact on the world, not just through your science, but also the way you do science every day. And Green Lab certification is also beneficial for research institutions by really demonstrating your sustainability commitments and pairing that with tangible action. You can realize cost savings from a lot of those resources that we're saving through our sustainability efforts. And more sustainable labs are often safer too. So there's a risk avoidance aspect to this too. The next program I want to bring your attention to is the Freezer Challenge. This is near and dear to my heart as I organize and manage this program currently. I'm a bit biased about the Freezer Challenge, and I love this program. It is free. Any lab in the world can do the Freezer Challenge, and it's running right now. And I would encourage you to sign up and be a part of it this year. It runs until July 1st. But there's still plenty of time. You've still got like 2 whole months to take action on your cold storage. And the Freezer Challenge over the last 5 years, the combined efforts of all the scientists doing the Freezer Challenge have saved 9.9 million kilowatt hours per year. Oh, I said 5 years. That's a stat over the last 4 years. My apologies. And yeah, so this is a way that you can focus in on your laboratories, refrigerators, and freezers. I would really encourage all of you to participate. We know that there are thousands of these units, millions of these units all over the world, and they are sitting there plugged in our labs 24/7, 7 days a week, 365 days a year. So the Freezer Challenge is about promoting best practices that are related to energy efficiency, but also the Freezer Challenge can benefit your lab because you can have better and easier access to your samples, either because you took care of that defrost that really needed to happen, or you're brushing the frost more regularly. You can also improve your sample integrity and the longevity of your samples by really paying attention to your cold storage and making sure that your freezer is not likely to fail, and reduce costs. And that's more of a benefit to your institution in reduced energy bills. And by participating in the Freezer Challenge, you get recognized. So if you win the Freezer Challenge, you get recognized at the annual International Institute for Sustainable Labs Conference, which is happening this fall in Atlanta, Georgia. And the labs and organizations that win the Freezer Challenge get featured in an article in Nature, which is super cool. And some of the institutions that have won recently and labs that have won recently are the University of Illinois, Urbana-Champaign, the Whitehead Institute, and MIT. The National Institutes of Health has participated, the Centers for Disease Control, the Multiple Sclerosis and Parkinson's Tissue Bank at Imperial College London, the Brain Inflammation Group at the University of Manchester. So I would love it to see a bunch of you participate in the Freezer Challenge if your lab does have cold storage. And if you have done anything with your cold storage that's listed on the Freezer Challenge score sheet since last August, it can count on this year's Freezer Challenge. So please sign up. That would be lovely. And again, it's a free program, and it'll really walk you through the best practices that are recommended by the lab sustainability community related to cold storage. Then there's the ACT label. This is a program that provides a nutrition label or an eco-nutrition label on laboratory products. And we have ACT labeled products that are consumable supplies, equipment, and also chemicals and reagents. And this program is really taking off and growing fast. We already have over almost 500 labels in our online database, and we will have almost 3,000 labels later on this year. So we work with manufacturers to get their products ACT labeled. And what this means for you as scientists is that there is a way for you to compare pipette tip to pipette tip and Petri dish to Petri dish and ultra low temperature freezer to ultra low temperature freezer. So a lot of manufacturers have internal eco labels or sustainability labels. Say Millipore Sigma has it in their product suite, or Thermo Fisher Scientific. But what the ACT label does that's different is it allows standardized comparison across manufacturers. It's third-party verified. So My Green Lab works with another organization, SMS Collaborative, and they do our third-party verification of the ACT label. And so anyone can use this tool. Our database is at act.mygreenlab.org. You can check it out. Our database is so much better than it was a month ago. We just had a whole new database in place, so it's awesome. And if you want to see other products ACT labeled, talk to your suppliers and vendors about getting it done. This is the way we provide, ACT stands for accountability, consistency, and transparency. So let's bring these three attributes to all of our scientific products. Finally, I know I'm running out of time, but I would like to invite you all to become My Green Lab ambassadors. This is a free program as well, designed for scientists and sustainability professionals that want a first start in approaching lab sustainability. And what's involved here in this program is we have some smart science training videos. They are short and sweet and kind of role play for you what it might look like for you to bring up lab sustainability in your lab group meeting, and how that conversation might go and how you could approach discussing these topics with your lab. And you watch the videos and you pass a quiz, you become a My Green Lab ambassador, and we hold monthly webinars on interesting topics. We just had someone speak about green chemistry and the Dozen 2.0 tool. And you're also linked up with this network of hundreds of other ambassadors. Right now, we're using Microsoft Teams as the platform where you can ask questions and share resources across the community. I think we're going to move to a different platform, though, that's more accessible to everybody. And this program isn't even a year old, and we have 500 ambassadors all over the world. So with that, I know I did a whole lot of talking just then, but I want to leave you with this thought from Jane Goodall. You cannot get through a single day without having an impact on the world around you. What you do makes a difference, and you have to decide what kind of difference you want to make. So with that, my contact information is here. You can reach us at info@mygreenlab.org or me directly, and I will take questions now. Thank you, everybody.
Thank you very much, Christina. This was very informative, and honestly, I wasn't aware of how much we were wasting in our labs. So thank you so much, and for giving us some advice and some tips about how to reduce our consumption. So if people have questions, please put them in the chat, and we'll ask them for you. I have a question first about the Green Lab certification. So you said that first we have to self-assess what we are consuming and how much we are consuming, and then
did we lose Lucy?
What's happening? Did you lose me, guys?
Maybe she's coming back, otherwise I will.
Can you hear me?
Yeah, I'll look through the chat and see.
Yeah. Anyway.
Yes, Can you hear me or not?
Yes, now we can.
Oh, okay. I think maybe I shouldn't have turned on the camera. I have a question about the certification that you guys are providing. So how do you assess the progress? Is somebody from your organization coming to the lab to make sure that what you wanted to implement is put into place, or how does it work exactly?
Yeah, so no, we are not coming on site to your institution to verify things. We do ask that greater than 50% of the individuals in your lab respond, and so we are hoping for a varied and truthful answer from all of your lab members. It is based on the honor system, so you're paying to do this program. Hopefully you want to get something out of it, something beneficial out of it, and really be able to enact change in your lab space. So you receive an online self-assessment, and everyone in the lab takes the assessment, and then we provide feedback. We can do that either in a PDF report format or as a PowerPoint presentation if your lab would like to go through a presentation together and kind of walk through the 14 different topic areas in the certification. Then you're given time to implement your changes, and your lab can decide what strategy you want to take. Maybe it's you focus in on a different topic every month. Maybe you pick 2 actions in each category, and you're going to spend 3 months trying to implement those, whatever works for your lab. But when you feel like you're ready, usually in a 3 to 6 month time frame, then everyone in your lab will take the self-assessment again, and then we certify you based on your improvement.
Okay. Yep. Okay. Thank you very much. So I'm just going to ask a few questions from our participants. We have a question that says, that talks about single waste plastic that we use to work on sterile microbiology. The question is, if we drastically increase the autoclave and dishwasher use, if we stop using this single waste plastic, so how would you suggest the trade-off, thinking about these kind of trade-offs between either using a single waste plastic or increasing the autoclave and dishwasher use?
Mm-hmm. Yeah, so I have not seen like a comprehensive like life cycle analysis or comparison between using certain types of single-use plastic versus using a reusable material that you then wash, which obviously requires water and reagents. I do think that this question has something to do with where in the United States or where in the world you live. If you are in a very water challenged part of the United States, say the desert states or in the West, it might make more sense to continue using single-use plastics. If you are in an area where water is plentiful, rainfall, reservoirs, that sort of thing, it might make more sense to transition. And you don't, obviously, we're not going to stop using plastic in our labs overnight, but there might be certain consumable supplies that you do use on a regular basis. Maybe it's not the largest volume thing that you use, but you use it consistently. maybe those are the things you want to invest in a reusable material for. I've heard of labs really successfully transitioning to glass Petri dishes and washing and reusing them for microbiology and doing, you know, the whole washing, sterilizing, and then plating out new agarose. But that's just one example. I do think the solution is larger. It's larger than just the scientists. You can do what you can, but we've really got to engage with the manufacturers on take-back programs and providing effective recycling programs that aren't just downcycling these plastic materials. So it is a tricky question. I'm sorry I don't have a clear answer for you. But I would say try it with some aspect of a consumable that you use and try the transition. My partner's lab that he did his PhD in, you know, they used glass pipettes, you know, the really long serological pipettes. They used glass ones, and they washed and reused them instead of using single-use plastics for those. And that was one specific area that they felt like they could do.
Okay. Well, then we still have 2 questions, if you don't mind us asking, because I know we are running out of time. So I have a question about bleach alternatives, because in the US in particular, we use a lot of bleach in our lab settings. And do you think that there are some alternatives that could be used instead of bleach?
You know, I've heard some chatter about this on the Ambassador Teams page. I don't know the specific names of the bleach alternatives off the top of my head, but whoever's asking this, Coraline, feel free to email me and I can connect you up with some people that are trying bleach alternatives. But yeah, I don't know specifically, you know, this is obviously one of the chemicals that's used very widely in science. And yeah, there might be more sustainable options available now that are safer for the environment.
Okay. One more question maybe. Are there any discussions with policymakers about making some of the actions you presented mandatory in the lab set?
Yeah, so some institutions are, so not at the government level, but some institutions are mandating changes. There's a variety of models out there of how this can be done. One thing that I think is really fascinating and an area that we might see more action soon is there's a group of people here in the United States that are trying to connect sustainable and efficient actions in labs with grant funding. And I can provide, they're called Better Grants. So Better Grants, they have a website, and Better stands for Bringing Efficiency to Research Grants. And the idea is that both scientists can voluntarily put statements in their grant applications about what they are doing to be sustainable, whether it's sharing equipment, buying Energy Star or water conserving products with their grant funds, trying to reuse things as much as possible and cutting down on single-use plastics. So voluntarily putting those statements in your grants. And eventually we may see granting agencies asking for this. And these folks that are leading the Better Grants effort, they are also talking directly with NSF, NIH, about this idea. We are already seeing movement on this front coming from the United Kingdom with one of their main funding bodies. And so we feel like it's only a matter of time. And so this would be a really important and interesting policy change. You know, the idea isn't to make more administrative burden on scientists to like put more into those very large grant applications, but can you show that your science is being done in the most efficient way possible? And can that give you a leg up in getting grant funding, which we know is so scarce and difficult to get in the first place? So that's one area where we're seeing, we're hoping to see change in the near future. So feel free to engage with that group if you're interested.
Yes, thank you very much. I'm just gonna take 2 more minutes of your time for one final question, if you don't mind. I mean, all the people that are here participating today are people that are interested into changing our behavior in the workplace and in the labs in general, but I don't know about the others, but sometimes in labs, not everybody is as engaged and as interested into having a less wasteful workplace and that are disengaged in this environmental issues. So do you have any tips on how to engage with our lab mates about making them want to do the changes that we want to implement in the lab?
Yeah. Yeah, obviously there will probably be people who are resistant to changing the way science is done. You know, in some cases, science is done the same way as it was done 30 years ago. In a lot of other ways, we have had incredible technological advances and even changes to our protocols. So I think meeting people where they're at is a good tip. And you also talk to that person that's resistant about making change, and maybe figure out what does speak to them, whether it's you know, a cost saving. So if it's the lab manager, maybe you could think about bringing up the topic of cost savings. If we're having to purchase less, if we're being more conscious with keeping a laboratory inventory, you know, let's save money for our lab, or let's save money in terms of energy and the water bill that comes to our institution. I know scientists don't pay their utility bills usually, so that makes that argument a little bit tricky. But maybe safety is something that speaks to people, and so you could talk about sustainable actions from a safety perspective. And there are some talks out there that more explicitly link safety and sustainability. I think there are some recordings of them. One of my colleagues at the University of Georgia speaks on this topic often. So if you want more ideas on that front, again, reach out to me and I'll try and connect you with resources I know of. And I also do think that, you know, if you have individuals in your lab that are hesitant, hopefully you can find some camaraderie and other champions that care about sustainability with you, and form a team and support one another as you go on this journey to figure out how you can do science in a better way. People who are resistant, they're gonna watch you, they're gonna see what you're doing, and you know, people's hearts soften over time, I would say, or it becomes more convenient to do the sustainable action, or they feel like, okay, like everyone else in my lab is doing this, I guess I'll get on board too. I would say don't worry too much about the people that are super resistant. It's a different story if there's a power dynamic where maybe your PI is not interested in sustainability. I know that can be difficult if you are a postdoc or a grad student. And trying to voice, you know, what's important to you, but also operate in that laboratory environment. But maybe there's a group of people outside of your lab that are interested in sustainability, and you kind of team up with them. You make changes, small changes in your lab, but then you share what you're doing with other labs so that you're amplifying your actions that way, even if it's not within your own laboratory. I hope that makes sense, but there are some different strategies you can take if you're meeting resistance. The ambassador training videos might be helpful for some of you that experience that, maybe some resistance to sustainability, some ways that you can approach this at your lab group meetings.
Okay, well, thank you very much for that. Well, I guess it's already a little bit late. I'm gonna take a minute to thank you again, Christina, for accepting our invitation tonight and to have given us that many tips, and hopefully we would have inspired people to join you in this organization and My Green Lab and get some certifications and some freezer challenge. I would like to thank all the people that have stayed with us and listened to this talk, and hopefully they can also maybe reach out to you for more information and to continue this journey with you and with us. Thank you again for joining us for this webinar, everyone, and we hope to see you for our next event next month. And thank you again. Bye.
Thanks, everybody. Have a good night.